Hello IB. I just want to run through a couple of things that we've learnt recently about using the TI Inspire. So if you've got an 84, then these won't be relevant. But yeah, it's just some things that we've learnt which could be helpful or make life a bit easier for you. So normally when you've got your Inspire and you reset it, or it's in test mode, you're in Radian mode, and you should see that at the top. And if you don't, then you need to update your software. So what if you have to do this sort of calculation, sine of 60 squared? So one of the things we've tended to do is keep turning your calculator into degrees or radians by changing the mode, but you can just simply put this in. So these are some new things we realized. So just by typing in your sine, now you want to go 60 degrees, so 60, and then you can put in the degree sign, which tells you your calculator that you're in degrees. So I'm looking at this little symbols at the top here for like, is it infinity and beta and the degree sign. So we put in the degree sign, and then that's there, and we can now just go enter, and it gives us this value, 0.866. So that's the ratio. And you should know that if we just test it to make sure we're right. So sine and 60 is pi on 3. So we could just go pi divided by 3, enter, and we get the same answer. So we know we're right. So your calculator, even though it's in radians, by putting that degree sign in, makes it work as if it's in degrees. The next one is, what if we're doing an inverse trig? So let's go inverse trig, and let's pick a nice ratio of 0.5, because you know the inverse trig of inverse sine of a half should be 30 degrees. Hopefully you know that, or pi on 6. So we get that answer. That's obviously in radians, because our calculator is in radians. So can we turn that radian value into a degree? To turn that into degrees, we just want to do our answer, and then we want to go to this function again. See this solid little triangle? So that turns it into, so it automatically brings down the previous answer. Turn it into, and if we type in DD, and I don't know what that stands for, but it does, and then that turns it into degrees. So it's something to do with degrees. If someone finds that out, they can let me know. So now we can turn our radians into degrees with 2 pushes of the button. Of course, you could have just done that by dividing by pi, multiplying by 180. So if you're in your radian mode and you want to turn that into a degrees, then this is your ratio. Your answer here is in radians, but now we can turn it into degrees. All right, so that's those two that we could look at and find another way of doing it on your calculator. The next one here is, if we have to solve a function like that. When you look at that, there's no way you can solve that, and not even at the end of year 12 can you solve that. So this will be in paper 2, and you're going to think immediately, I've got my calculator, so let me graph this up. What I also want to put in here is for a given domain. So I'm going to choose a domain in this case of, I've worked it out, -3 is less than or equal to x less than or equal to 2. So I've often said, use this domain here to set the window on your calculator. There's another way of doing that, which some of you already know about doing, and it's your call which way you want to work with this. So let's go to my calculator page, my graphing page. So if I want to put in trig sine e to the x, and next function is, we're going to go enter. So there's that. Whoa, crazy function. And let's put our next one in, which is 2x squared minus 3 it was, and graph that one. So there are 2 functions. All right, And what we could do is limit the window. So you can either go to Window and set your, jumped away from that, set that in your window settings into that domain. Another way of doing that is when you're typing in your actual function, set your domain straight away. And if you want to set your domain, what you can do is go over to here. See, there's that vertical sign, not equals, greater than equals to. So that vertical line, remember that's such that, and we use that with our domains. So we want to graph this such that -3 is less than or equal to, is our less than or equal to x, which is less than or equal to +2. So now, can you see what's happened with our graph? It's just been shortened for the given domain. But I've still got the full axis just to get the global picture of what we're graphing. Let's do the same for our next other function. So just go back up to that function and we'll put in the domain. So remember, you go Control where that equal sign is, such that, and we've got -3. I'm just going to go there, less than or equal to. I'm not sure whether there's a difference whether you go less than or equal to or just less than, but I'll just do the same. 2. Alright, enter. And now see, both of them have been restricted to the domain that we've put in, and now that's in our label. There. Alright, so there's our two labels. Now, if we want to now get the solution, we're after our points of intersection. Of course, you know how to do that. To analyze, our intersection is 4, lower bound up through there, and we come up with our intersections. So I've set this up already here on this other tab, and there are two solutions. So x is equal to 1.19 or x equals -1.28. Now here, we're only getting our 3 decimal places shown, and if you want to go more, then you do need to change your document. Oh, that document setting is 6 there, so I need to have changed this one in our graph. On the settings number 9, it's only floating at 3. Alright, so if I want to get more, then I need to put it up higher, and I get some more significant figures. So if you need more, that's where you need to change that. Alright, another way of doing that is from a calculator page. So here we're trying to solve this equation, so we can just type that into our calculator page by going to Menu, Algebra, Option 3, Numerical Solve, NSolve. So we can just type this in, trig, oh, okay, so we want trig sine e to the x, where are we, e to the x, and we're going to come out of there, equals to, no, we, oh, hold it, sorry, go back, we need to stay inside here, inside that main bracket. So we're going equals here, we're inside the bracket, 2x squared minus 3, we're all inside. We want to solve it for x, so we need to tell the calculator that, so comma x, and then enter, and see, we come out with that answer. So here you didn't actually have to graph that up. In the IB, I still would like to see a graph of some sort of working, because if you type that in and you don't have any graph, I'm a bit concerned that you haven't really shown your understanding. So note here, it's given us this answer. What the calculator will do automatically is to give you the answer that's closest to the y-axis. So in this case, that's closer than the other one. So on the graph, you can see there are two answers, but if you just do the NSolve, you'll only see the one answer. And and we can put in here, let's see if I can go back. I'll go up, enter, and we can end solve. I think at this point we can go given, let's try it here, given x is less than, oh, we got less than, x is less than 0. So if we get a negative, we want the negative answer. So now it's gone and given us our negative answer, minus 1.279, minus 1.28, which was, there's that other answer it's given us. So if you just want to use end solve, you can, but just be wary that it doesn't give you two answers. It'll only ever give you one answer. So be careful about using that one. I would always graph it to be on the safe side to see that there were two answers. If you know, you could do x is greater than 0 and x is less than 0 and get your two answers that way. But if there were two of them in the positive region, then that wouldn't have helped either. So just be careful using end solve. It's another strategy, but you've just got to be a little bit, I just think doing your graph, setting it up for your domain helps you realize what points are in that domain and how many solutions you're going to have. So anyway, there's a few little things you can use hopefully with your calculators. Thanks for listening. Bye for now.